So today we're talking about section 9.6, solving exponential and logarithmic equations. First thing we need to remember is that when you have a log base a of x and the log base a of y, if these are both the log base of the same thing, then whatever you're taking the log of, if the logs are equal, then the actual items are equal. So then x equals y, and obviously x and y must both be greater than 0 because you can't take the log of 0 and you can't take the log of a negative number. If you have b to the x equals b to the y and the bases are the same, then the same thing is true here. Then x equals y, and in this case the base itself can't be -1, 0, or 1. And the reason is if you put a -1 or a 1 to a power, it's just 1 or -1, and if you put 0 to a power, it's just 0. So that doesn't really have anything to do with what the exponents actually are. So let's look at the first question. 4 to the 3x equals 16. Now the key here, this is really important, you might want to write this down. Get the same base. Here I have a base 4 and a base of 16. This is really like 16 to the first power. Those are not the same. But if I could make them the same, life would be good. I can make 16 have a base 4 by saying 4 squared. Do you agree that 4 squared is 16? Yes. So we have 4 to the 3x equals 4 squared, and using this rule right here, we can see that when the bases are the same, the exponents are equal. So now you can write your equation 3x equals 2, and then you just solve. X equals 2/3. Kind of a nice little problem there. Looks kind of crazy to start, but that works. And you can test it out and check it. If you plug 2/3 in here for x, 3 times 2/3 is 2, and 4 squared is 16. Here is 7 to the x minus 2, excuse my little mistake, equals 60. So here we need to get the bases the same, or we at least need to try. Can you make, is 7 to anything 60? No, because 7 squared is 49 and 7 cubed I think is 243. So it's neither one of those is going to hit 60. So then we have, obviously that's not always going to work. So our other trick is if we take the log of both sides. So what you're going to do is you're going to take the log base 7. You take the log base this number, whatever this number is, of both sides. So of 7 to the x minus 2 equals log base 7 of 60. Do you see that as long as you do something to the left, you have to do it to the right. So here we can use the power rule and say this exponent comes out front and becomes x minus 2 times this. And log base 7 of 7 just cancels. Some of you know that it just cancels into 1 and you know your exponents left. But if you need to use that power rule first, that's fine. But either way, we're left with x minus 2 equals log base 7 of 60. Now on the test, I'm going to want you to give me exact answers and decimal approximations. So to solve for x, we obviously have to add 2 to both sides. That is the exact answer. There's no simplifying that can be done there. 2 plus log base 7 of 60. Then yes, you can type that into your calculator and you get approximately 4.1041. So go ahead and try that out. Okay, this next one, e to the 0.06t equals 1500. Well, as we learned, if you can't get the bases the same, which you can't on e to n 1500, you can take the log of both sides. Now think, log base what? If we go back to this one, we took the log base, whatever the base was in the problem. So the base here is e. So you have to take the log base e of both sides. E to the 0.06t and 1500. And yes, these cancel. 0.06t equals log base e of 1500, and then you just divide by 0.06. So log base e of 1500. Now hopefully some of you are starting to question my sanity here, because log base e, we have a name for that. Log base e is natural log. So right from that step, I could have taken just the natural log of both sides, and then these cancel, and just divide by 0.06. This is a better answer, but if you type them both in the calculator, you will get the same thing. Log base e is natural log. And the decimal approximation for that, I believe, is 121.89. And the test does ask for both. Okay? So the next thing we're going to do is write out our steps. And this is to solve when you have a to the t equals b for t. So this is something when you want to solve for that exponent. Some of you were concerned when the the variables start to go up in the exponent. Now here's how you solve. We just did it. Step 1. Take log base a, in this case it's an a, base whatever that number is, of both sides. Step 2, solve for variable. Like in this case, we had to then divide by 0.06. And step 3, check. Now think for a second about why do you think checking is really important in logs. Sometimes logs will give us extraneous solutions, and that is because you can't take the log of a negative number. So if this was like negative 1500, I can't take the log of a negative 1500. You can't take the log of a negative number, so then there would be no solution there. Okay, let's try another one. Log base 4 of x, 8 minus x, 8x minus 6, my goodness, equals 3. Go ahead and write that down. And anytime you have a situation like this, you got to always remember all the tools in the toolbox. We're not going to take the log of both sides. This is not using our steps because that was when we want to solve for the exponent. But we do know a trick. Left to the right equals middle. So our left number is 4, our right number is 3, and our middle is 8x minus 6. Okay, you go ahead and finish this one and reduce it. Cube the 4, and then solve for x. Add 6, divide by 8. ln of 5x equals 27. Again, I'd like to use left to the right equals middle, but I don't see a left number. What base goes down here? Well, if it was a log, we would assume base 10, but it's a natural log. So that's base e. And you can write that if that helps you. So now we have e to the 27th equals 5x. And then we just divide both sides by 5. X equals e to the 27th over 5. And actually, I wouldn't even put that in your calculator. That's such a huge number. I don't even think it'll give it to you. Okay? Now if you have log x plus log x minus 3 equals 1, we have to use our rules to condense it. I have 2 logs here, but they're being added, so I can condense that into 1 log and do what with the parts? Multiply them. Now, here I don't have a base, so it's an implied base 10 because it's a log. So I have left to the right equals middle. And as I write this, I'm going to distribute. Now we have a quadratic. So I'm going to go ahead and move over the 10, set it equal to 0, and it's factorable. Multiples of negative 10 that add up to negative 3, negative 5 and plus 2. So our solutions are positive 5 and negative 2. Now here's something where you need to check. You need to check in all these. This is the first one that matters. Log of, if we were checking the 5, log of 5, oh that's fine. Log of 5 minus 3, that's log of 2, that's fine. But here I have log of negative 2. You can't take the log of a negative number. So your answer is just 5. So you might want to write that down. You can't take the log of a negative number. You can't take the log of a negative number. Okay. Here we have log base 2 of x plus 7 minus log base 2 of x minus 7 equals 3. So the first thing we can do is condense, and it's log base 2, and subtracting turns into division. And if you're not familiar with what to do with adding and the subtracting, you definitely need to go back and watch the old videos, and you definitely need to get that before the test, because lots of these are solving, and they're not that difficult, but if you forget that, you'll be stuck. Left to the right equals middle. 2 to the third equals x plus 7 over x minus 7. 2 to the third is 8. And I'm going to multiply both sides times x times the denominator. So I have 8x minus 56 equals x plus 7. Okay, look at that for a moment. And now we just solve. Subtract it, 7x equals 63, so x equals 9. And now check. 9 plus 7, yep, that's positive. 9 minus 7, that's 2, that's positive. So it works. You're just making sure that you're not going to end up taking the log of a negative. Here we have log base 7 of x plus 1. Plus log base 7 of x minus 1 equals log base 7 of 8. So you should see that right away you need to condense these. Log base 7 of, and they're adding, so we multiply them. Oops, that's a 1. And now I have the log base 7 and log base 7 of two things. So what's true about these things? Look back at the very first rule we wrote down today, and it means that they're equal. So then we need to go ahead and FOIL x squared. Outside inside cancel, minus 1 equals 8. X squared equals 9. So x equals plus or minus 3. Now check. Let's check the plus 3. 3 plus 1, that's good. 3 minus 1, that's good. Let's check the minus 3. Negative 3 plus 1 is negative 2. The minus doesn't work. So it's just x equals 3. The negative does not work. So go through these, practice these, do these on Math Excel. You will see these on the test. Let me know if you have any questions.